Hi, this is the first video introducing the topic of piecewise functions. A piecewise function is literally a function that is divided in pieces, or split in parts. And it will be something like here. I have my function, in this case is a f of x here, and then it's divided by, I use this symbol here to open a window here, and just to say that this f of x will have the value or the structure or the form of x plus 3 when or if, this comma stands for when or if, when x has a value that is lesser or equal than 1. See? So it could be read that f of x is x plus 3 when x is lesser or equal to 1. So I'm going to write here on the left, on the right here, how would like we use this notation for the x lesser or equal than 1. This would be from negative infinite to 1. That is to say, in this interval you are going to use this structure, this function, right? And we use here this bracket here because we are including the 1 in this interval because of this lesser or equal symbol here. So now I want to notice something. This one here, you very likely you will not find in a textbook or in a textbook, because normally you will only find this form here, only this part. I just wanted to tell you it's just the same thing because you get confused by this notation. But okay, let's follow on with the second part of this f of x. And then after this x plus 3 is saying that f of x will be x squared minus 2 when or if x is greater than 1. So this would be, in any case we have a value above 1, for example, I don't know, 2 or 10 or 100, we're going to use this function to evaluate f of x, not the other one. I'm going to write here the notation. It would be within a parenthesis with a 1 to infinite, positive infinite, because here we use a parenthesis here because we are not including the 1. This is a greater symbol, not a greater or equal. Okay, let's proceed to do just 3 or 4 examples here to show how you would use this notation here. I'm going to use different color here. In here, okay, let's see. Let's say we want to use I want to evaluate f of, I don't know, negative 2. F of negative 2. Well, in this case, we have to look for within the ranges here we have and see where this negative 2 falls in. And obviously it falls in this interval here, or because it's lesser or equal than 1. So we have to use this function here. Now I'm going to use this one here will be negative 2 plus 3, and f of negative 2 will be equal to positive 1. And that will be it. Now I'm going to use another example here. Let's say I have f of 5, and I have here, well, 5 is above 1, so it falls as well in this interval. So I'm going to use that one, the blue one here, x squared minus 2. It would be here 5 squared minus 2 would be 25 minus 2. This would be 23. And that will be it with the f of 5. I'm going to do another one just to show you something. I'm going to look for f of 0. Well, 0 falls actually, I'm sorry, I think it's better if I start with this one, f of 1. Yes, f of 1. Now f of 1, well, you know, here where the question will be where is included the f of 1. F of 1, it's included in this one here because it's a lesser or equal symbol here. So we have to evaluate in this expression here. I'm going to do it in here. Will be 1 plus 3. It will go to 4. Well, that will be pretty much it. So basically, the thing with this evaluating piecewise function, you have to look for where the value you're trying to evaluate falls in which interval, and that will be pretty much it. Just keep in mind the notation. Piecewise functions are functions divided by pieces, and these pieces are structured in like this way. You have the statement, this comma that stands for a when or if, and then you have the interval. Okay, now let's move to some other example and then to graphing out these functions.